course wrap-up. It's not necessarily about a specific statistical method or statistical idea. It's just to sort of summarize some of the key ideas and some of the things I'm excited about with data analysis and hopefully set you up for the next set of adventures that you're going to have with data. So the first thing that I want you to keep in mind is the reason why you do applied statistics is because it's not the critic who counts. This is actually one of my favorite quotes, and it comes from the 26th President of the United States, Theodore Roosevelt. And basically what he's pointing out is it's not the person who points out how someone else is making mistakes or is doing things wrong. It's actually about the person who tries to do things and tries to answer questions. And I think that's really true of data analysis. A lot of data analysis is about trial and error. It's about experimentation, and it's about learning from experience. And so I hope that you'll take the lessons that you've learned in this class and try a lot of them out on your own data sets. You can read a little bit more about what we think about this at our blog in a post called Statistics in the Science Game. Remember that I talked about at the beginning of the class that the key challenge in applied statistics is when you ask yourself what problem you've solved that was worth solving, where you either knew all of the given information in advance and you didn't either have to filter some of it out or go out and find some new information. I think this is the key issue in data analysis. I hope I've given you sort of the very basic tools for doing that in applied statistics and data analysis with what we've covered in this class. But in general, I think the best way to learn about data analysis is to take these basic tools and then look at the further resources that we've talked about and really dive deep into the particular applications that you care about. So why do data analysis or applied statistics now? Well, now is the time that is most exciting to do data analysis, as has been recognized by The Economist in their recent cover that talks about the data deluge, or in the New York Times, which talks about how one of the best new jobs to have is in applied statistics, as pointed out by folks at good places like Google. It's also been recognized by places like the McKinsey Institute as an area of growth and an area of opportunity. So I hope that you'll take the lessons that you've learned in our data analysis class and carry them forward to hopefully take advantage of the many opportunities that are going to be available for data analysts going forward in the future. It's a particularly lucky time to be a data analyst. I think it's because it's sort of the, just like when the World Wide Web was sort of just taking off and when some of these World Wide Web companies were sort of exploding, it's a similar time for data. There's sort of a lot of excitement and a lot of opportunity to take advantage of low-hanging fruit if you have a few data analysis skills like I hope you've picked up in this class, and the sort of grit and determination to carry them forward. You're also lucky because there are websites like Kaggle, which allows you to perform data analysis competitions, which didn't exist when I first started learning about statistics, but I think are a great addition to the overall sort of milieu of what you can do with data. And I hope that some of you will take advantage of what we've learned here, but really go learn a lot more about prediction and the specific details that you need to learn to win these competitions, and try your hand and see if you can win a few of those $1 million. An important thing to keep in mind when doing data analysis is that the best new statistical ideas are almost always driven by new types of data and new advances. And the interesting thing is right now is a time where there are a whole bunch of new different types of data that are being generated. And I think this provides a huge opportunity for people who are interested in taking the next step and not just doing data analysis, but deriving the next set of sort of statistical methodology or data analysis methodology to answer the questions that are most pressing to us. So a lot of statistics we learned about in this class, for example, the T statistic was developed as a way to measure the differences in quality of beer across different samples. Analysis of variance was developed to sort of identify which field characteristics led to better crop yields. Then more recent examples include things like Kaplan-Meier estimators, which we didn't go over in class, but you can read about here, which were developed to sort of to measure, analyze survival times, particular survival times where people were not lost to follow-up in studies. And then more recently even than that, say recommender systems like that Netflix uses for recommending the next movie you want to watch are based on lots of other people's movie ratings, and so this is a new kind of data that required a new kind of statistical method. And I think with all the new data being developed, there's sort of a huge opportunity for people who are interested in learning a little bit more about how to develop new statistical methods to take advantage of these data. Who is an applied statistician? I think this is an important question. Who's an applied statistician or a data analyst? These are all examples of people that I sort of admire that analyze data. Daryl Morey, who's the GM of the Houston Rockets, and Hillary Mason, who's the chief scientist at Bitly. Daphne Kohler, who helped found the Coursera company, which is why you're taking this class, and Nate Silver, who runs the 538 blog. Each of these people analyzes data for a living and might have a slightly different title, but they're all trying to answer sort of the most pressing questions with the newest, most interesting data. And I think there's an opportunity for you to put your face up on this board as somebody that tackles a new and interesting data type with techniques we've learned in this class or elsewhere to answer some of our most pressing questions. An important goal of this class, but in general, my goal in education is to sort of put you in the right place to do what's called, I guess, data science. So this is a Venn diagram originally created by Drew Conway, and he talks about how you need a little bit of math and statistics knowledge, which I hope I've covered in this class, a little bit of hacking skills, which again I hope I've covered in this class, and then also some substantive experience. So whatever area that you're working on in business or science, you need to have a little bit of knowledge as well. The intersection of all of these components leads to good data science. What you want to try to avoid is sort of the danger zone. So not having any knowledge of math and statistics, but just being able to sort of get some data and do things with it can lead you very quickly into the danger zone. So I hope I've sort of tried to pull people away from the danger zone with this class. But in general, keep in mind that just because you can do an analysis, it's important to evaluate it critically and determine whether it sort of makes sense in terms of the statistical methodology, but also in terms of the processing and the choices that you made. So I'm just going to point again to a couple of resources that I find to be very useful and I think might be useful for you going forward. So this Open Intro textbook, which is a free textbook including exercises about statistics, basic statistics and probability. I think even if you've taken this class that we've gone over in today, sort of this data analysis class, I think a basic grounding in statistical ideas is a really good place to start if you're going to kind of move forward in data analysis. The Elements of Statistical Learning is a sort of an outstanding textbook if you're going to be doing anything involving prediction or anything involving sort of machine learning, and it's available actually for free as a download, but it's also a great book to just have in your collection. This is again a book that isn't published yet, but hopefully will be published very soon, and is also available as a free download, which is Advanced Data Analysis from an Elementary Point of View. This is substantially more mathematical than the level that we've covered in this class, but is certainly worth a read if you're going to be doing data analysis in the future. So I also thought I'd make just a list of a few other things that I think are worth reading and kind of fun to check out. So Andrew Gelman and Larry Wasserman are two statisticians who have blogs. Stats Blogs is an aggregator of different statistics blogs. Flowing Data and Junk Charts are blogs about data visualization. Hillary Mason has a very nice blog, and her Twitter account also consistently has interesting, cool links about data. Cosmo Schlese, who's the guy that wrote that Advanced Data Analysis from an Elementary Point of View, has a very interesting and far wide-ranging blog. Then there's the Simply Statistics blog, which I write, which I hope you'll continue to read. And then if you have found yourself inspired and want to learn a lot more about data analysis and statistics, I hope you'll consider coming to the top biostatistics department in the world here at Johns Hopkins. Of course, there's no bias in that claim, but hopefully you'll consider us if you're thinking about going any further with your education. It's been my extreme pleasure to teach this Coursera class. I really appreciate all of the dedication, time, and enthusiasm you've all put into the class. It wouldn't have been even a tiny fraction as good without all of that great enthusiasm. It's been a wonderful experience for me, and I hope you've learned a little bit and also had a very good experience, and I hope to see you the next time I teach the class. Thanks.